What is up, guys? My name is Cherno. Welcome back to another Cherno live stream on the last day of June. Last day of the financial year in Australia. Last day of... We're halfway through the year. What else is significant about today? Crazy. Time flies. I also kind of wanted to get the renderer done. This new renderer done in June, which, you know, it's getting there. But I'm hoping today we can make some major progress on it. And work out some of the big things that need to be done. But yeah, we're gonna see how we go, because I thought a little bit about the stuff that we were working on. And I've kind of come to the conclusion that we basically need to sort of change the way that we deal with samplers in general. Because, well, first of all, if we want to support DirectX, which we do, this whole like combined image sampler situation that Vulkan offers needs to basically change, because we kind of need to separate samplers and textures. I think that's probably the big thing, and we've already been doing that to an extent, so it shouldn't be like too much of a... It will affect all of our actual shaders, but it's not like... We have been doing it a little bit in the stuff that's actually rendering in the new renderer at the moment. So because we wrote the IMGUI shader in HLSL, it basically means that we had to write it the HLSL way, which was by kind of separating out this texture and sampler. Now the sampler was bound at an offset of 128, whereas you can see the texture is bound at kind of binding point 0 here. The reason why is because I think the way that this is simulated, or the way that this is kind of done in... so what happens is, technically in HLSL, we have these different binding points for different types of things we bind, right? So S for sampler, T for texture. So that's why this is in S0 and this is in T0. That doesn't exist in GLSL, or like specifically in, I guess, Vulkan / OpenGL. Which is why the way that NVRHI deals with having this distinction is it just uses offsets. So we're basically saying that 0 through 127 is for like textures. 128 through, you know, 255 is samplers. And then there's two more, I think, and I'm not going to remember them. But if you go to like Vulkan resource bindings, I think that's where we have this this offset. So you can see that there's a register offset, and that register offset for resource type here they are, right? So we have a shader resource at 0. We have a sampler at 128. So 128 to 255 is for samplers. Constant buffers are from 256 to 383. And then from 384 to like, I guess, 511, we have unordered, well, plus, we have unordered access buffers, which are basically storage buffers. So that's basically how NVRHI does this, and you can see it describes compile time settings for HLSL to SPERV register allocation, because the way the registers work is different. Now, what's interesting here is that you can see constant buffers actually have an offset of 256, which I just noticed now live, and that actually might be an issue, because one of our current issues, I think, is that we're trying to get the renderer 2D working, and that requires a constant buffer, aka uniform buffer, over here. So you can see we have a camera buffer in set 1 binding, it says 0, which contains our view projection matrix, which is obviously very important for rendering anything in you know, in the scene, because it's our camera. And this, I think, may actually be offset by a bunch, which means that technically we have to bind that to like, you know, 384 or whatever. Now, we'll investigate this in a minute. I had a little bit of a play around with this off stream, which is rare, because since we started working on this and I started streaming consistently, I basically didn't look at anything off stream. But after last stream, I was a little bit curious. So I had a little bit of a dig through some code and I tried some things. So this will be very slightly different from where I left it last time, but not much. And this was last week, so I'm gonna have to remember what I did exactly. But we're still back in Renderer 2D and we're still trying to get lines to render in 3D space. That's just randomly the first thing we've decided to do. Did you not revert the things? What things are you talking about? The stuff that well, first of all, I didn't commit at the end of last stream, but also I didn't do any, by played around, I mean, I kind of did a little bit more work. Like I didn't just mess stuff up and leave it. It's in the right direction, so I'm going to build on it instead. I didn't do too much though. I'm pretty sure all I did was, I think I kind of remember what I did. I think in the Vulkan shader compiler or in Vulkan shader, yes. So this is what I did, I remember now. So I basically added a new render input type to our, shader resources here, which is an image sampler. And you can see this image sampler doesn't specify if it's 1D, 2D, or 3D. So we had these samplers, but I added just this image sampler. And the reason why is because if we have a look at, for example, this just says sampler. It's not like specifically a 2D sampler. And so what was happening was that I think in the Vulkan shader compiler as well, we were specifically looking at the dimension. However, it was a chance, not in sampled images, but in separate samplers, there was a chance, so you can see I disabled this, that basically if it's a separate sampler, let's just keep the dimension at 0 is what I kind of decided. And that way, if the dimension is 0, it just tells us that we are specifically like a sampler. And I think if we look at separate samplers, yeah, there's a case 0. So at the moment, these don't actually get set. And this is further confusing because inside that shader compiler, the way that this is treated is if you look at the base type image dimension, you can see that it's set to this dim thing, right? And this dim thing is, you can see that 1D is actually 0. So there's no dimensionless thing. Like, of course, I guess we could set it to dim max, but 0 kind of is 1 dimension. So it's a bit weird. And yeah, we also have cube, which is used as well if you have like a texture cube sampler or something. Anyway, I need to refamiliarize myself with this at all. So, what am I saying? At all. As well. So, you'll kind of, if you're confused, then don't worry because I am as well. And as I remember things, I will let you know as well. Yes. So what that means, but there's another implication here, which is people keep bringing up Slang or Slang, I guess, Shaderlang. I don't know how people say it. Slang, I guess, which is basically, I guess I can open it here. The Slang shading language. So here it is / here it is, and you can actually play around with it in a little playground, which is cool. This is basically a shading language that looks a lot like HLSL, but it compiles into lots of different things, and it also includes reflections. So if you can see over here, it's aware of everything that is in it, which is nice. It can reflect over literally everything that's written here, which is great. And you can compile it into basically everything, including like metal and HLSL, GLSL, SPURV, like whatever really, which is great. Actually, it even compiles into C++, apparently. Just into like, yeah, C++ code. So you can run it like on the CPU if you want, which is cool. Like, I think it's cool. I definitely need to do a bit more research probably on it before I just, commit to using it, because it's going to probably be a decent feature kind of to implement. So I don't think we'll do it initially, but we might do it in the future. And the fact that we might do it in the future, and like the reflection system is something that I think is good to have. We have SPURV reflect. We have SPURV cross, which can compile into HLSL or into metal. So all of these features are kind of implemented already. It's just that there are a little bit more nuances like with it, because a lot of them are implemented, well, that stuff is implemented by Kronos. And so they kind of make things more GLSL-y. I was talking recently about how generally HLSL, if I go to hazelengine.com and we have a look at Just ban some people. Let me, if we have a look at hazelengine.com, there's this Millinode board button. Excuse me. And there's this roadmap to release, which has this render 2025 in it. And you can see one of the considerations that we actually had here was that maybe we should possibly drop support for GLSL to reduce pipeline complexity. And at the time I was thinking of just switching to HLSL. And the reason why is because GLSL can't actually compile to DXIL and DXBC, which is DirectX 12 and DirectX 11. But HLSL can compile to SPIRV, which is for Vulkan. So technically, if we wrote our shaders in HLSL, we would never have to cross-compile. Whereas a pipeline with GLSL could still work. You would basically write your shaders in GLSL, but then use SPIRV, then compile it to SPIRV, and then use SPIRV cross to compile it from SPIRV bytecode to HLSL, and then feed that into the, you know, DXIL and DXBC compilers, which, you know, is more steps and I feel like is more dodgy. So therefore HLSL would be a better choice technically because it would just reduce complexity. But I also know that I think maybe I'm wrong actually. I thought maybe there was something planned that would help with like reducing the steps. I forgot what it was though. But anyway, so that might be a reason to use HLSL. But one thing I really don't like about HLSL is having to do all this VK stuff. Now, technically, I don't think you need this. This in this case might actually be automatically added or whatever. I mean, it won't be though. This won't be. That's the thing. Like for Vulkan, when we compile to SPIRV, we actually I think we need this declaration here, which is a little bit annoying. And then we can just ignore it for DirectX because it will use S0 and T0 and that's done. So that's why I'm thinking maybe something like, but see, that's the thing. Like, I don't know how we would even set this up in Slang. Do people say Slang or S-Slang? I keep wanting to say S-Slang. I don't know why. But I don't know how I would set up specifically like for this to be at 128 for when it gets compiled into SPIRV, and for something else if it's not. Like the way that I feel like you do that. So how does the image sampling work? Where can I see them sampling? Here's an image. Yeah, well, they don't even write a thing for it. So how does that look? Yeah, so I guess it works how to register for it automatically. See, I don't really like that either. And then what, you have to reflect on that to see where it actually ends up. I mean, that could work. Yeah, I guess, technically speaking, if we supported this, we probably wouldn't need to worry about this offset stuff because we could actually... Yeah, basically what what's up is saying, we could just let it be and then reflect to see where it is. And then obviously based on the runtime render API, you could be like, okay, it has to be in this slot. So we could definitely make that system work. We'd probably have to go into NVRHI and change some things though, which I don't mind doing. Because I don't really love their little offset table, to be honest. Which is, I don't know how I would solve it though, so I'm not saying it's like, how dare they, but I will say that I'm not the biggest fan of these offsets. Yeah, but anyway, I think for now, we will ignore this and probably just... We'll continue on with this. I think we'll just kind of continue on with this and we'll make it work with this current system because we're not too far off, to be honest. No, the reason, implodey, the reason why needs to be used is because NVRHI is set up to specifically offset Vulkan binding offsets, right? So depending on what type where we are, it actually offsets the binding point. So if we want to use a sampler, it has to be at binding 128. Because basically what will happen is when it binds everything, which is like here, you can see it has a register offset, which say for a sampler, well, for everything really, but for a sampler, for example, it will actually add that register offset with the binding slot that you specify. So if you say 0 here, then it's going to be 128 plus 0 for a sampler. And then that's the right descriptor set that it generates. It'll be at that binding location. So that's why we need this. But again, you know, if we did use Slang and we had it generate appropriate HLSL and GLSL code, well, more or less the correct bytecode, then I guess we probably wouldn't need these offsets. It would just kind of work because we would know the offsets at reflection time. Well, not the offsets, but the binding points at reflection time. And because in Hazel we bind by name anyway, like, you know, when we have these inputs, for example, into our render passes, we specifically say, where are the render passes? Yeah, we set our inputs by name. So we don't ever address binding points explicitly in the code that you write, in the high level render pass code, which means that we don't care where they are at all. And it doesn't have to reflect what's written in the shader. And by reflect, I didn't mean reflection, I meant human reflect. It doesn't have to mirror what's in the shader. It's by name, so it doesn't matter what happens under the hood. So that means that yeah, that either systems can work and it doesn't matter too much. The only downside at the moment, I believe, with the way that this is set up, is that sorry, one sec. The only like downside I think to this, with the way that it's currently set up, is that we have to go through all of our shaders and separate out samplers and textures, which I'm honestly not too opposed with doing, just because we've been using combined image samplers everywhere, which is I don't know if it's my preferred way to do it or if it's just lazy, but obviously that's like the OpenGL Vulkan way of doing things, whereas in DirectX you don't really do that. You pretty much always have samplers and textures, and you can do that in GLSL, like that's fine. You can just have a sampler and a texture separated as well, but it's just not that common. Like people usually like to combine them. And I think what tends to happen is, for example, like if we go to render a 2D text, you know, which samples a texture, I think what generally happens is, which is kind of fine, is you change this to just be texture 2D, and then you have just sampler, and that sampler, you know, you can just have one of them at like a different binding point. So I guess this would technically, so this is where it gets a little bit confusing, because this, I feel like at the moment, the way the code's written in NVRHI is this would be offset to register like 129, right? 129, because 128 is the offset plus whatever we specify here. So it's a bit weird. But it also doesn't matter because we're gonna address it by name. But anyway, if you do something like this, and then when you, I guess you can still use texture size. When you do texture, you then do sampler 2D or whatever, and then you put that in here. So something like that, I believe. And then that allows you to obviously use a separate sampler, like to specify. Oh, sorry. I gotta look up the syntax for this actually, because I think you can take in a sampler, and then that's well, is that correct? No, because texture takes in texture coordinate, right? So you have the texture probably is at first or second, and then texture coordinate is an input into the texture function. But then for sampler, you have that, comma, your actual sampler, which would be font alias sampler. So you basically have this, I believe. I think that's valid GLSL. That allows shifting bindings in Vulkan, works in Slang as well, sure. But anyway, so that might be something that we do. And it doesn't matter for this at all. Okay, well, let's just quickly run this. I just want to see if that shader compiles. I also updated Visual Studio, so we're gonna have to recompile everything. But regardless, we have this camera at what appears to be binding 0, but really that might be wrong. And I guess the way that it's set up right now would mean that it's actually up to the shader compiler to read that offset table. So there's Vulkan binding offsets, right? Which is a struct. You can actually set your own compile time, I guess, offsets. Let's see if this compiles. Or if it doesn't. Because it should recompile all the shaders. Well, it won't recompile all of them, but here we go, yeah. So texture size required extension not requested. That's the only problem it had was texture size? Oh, sampler less texture functions. Because it wants a sampler. So texture size actually wants a sampler. So what we can do is we just have to do the same thing. It's very easy. We just do this instead of that, and that should fix that. We don't need to use any extensions. Okay. So yeah. So basically, like, let's not worry about samplers. Let's not worry about any of this at the moment. I want to worry about this, which is the uniform buffer situation, because I believe this is like, we're trying to get these lines rendered, and I think, oh, did this work now? What? Since when do I not have this installed? That's a little bit weird. That's weird. I did not expect to get that. How do I not have that installed? I mean, I did. Let's just try install it again. I did run the Visual Studio installer. Maybe it like uninstalled a version. That's a bit weird though, because you can uninstall stuff using the installer as well. But that's very strange, because I wouldn't have thought that I would have done that. Very strange. That was unexpected. Okay, this looks better, I think. If it maximizes, it's good. Alright. Okay, yeah. So this is where we're up to at the moment. So we got a when it's trying to actually render it, we have an issue here. The other problem-ish that I can detect with this is that which we might need to investigate, and I will certainly do that now, is that basically the way that this is set up is you can see that camera is actually in set 1. And the reason why is because the camera doesn't change every draw call. So we store it in set 1. Now, we store like set 0 is like, for us it's like from the lower the number, the more frequently changing it is. So set 1 is like basically once per frame or something, or sorry, once per render pass, something like that. I think 2 is once per frame and 3 is like permanent. But that's like a loose definition. It's just in order of kind of frequency. So set 1. So basically the way that this is set up is because this line shader does not have any textures whatsoever, we actually don't have anything in set 0. We just have something in set 1. And this is what I was doing last week off stream a little bit. I was trying to get this to work and kind of thinking through it a little bit. And I was like, okay, well, is that fine? Like, can we just set something up can we set up these descriptor sets where descriptor set 0 just has nothing and descriptor set 1 has, in this case, 1 constant buffer or 1 uniform buffer? And I'm pretty sure that you can, considering this is not a new shader, but it's we are getting a crash where it says binding was null pointer. So I don't know exactly what that means, but I can guess that maybe it means that there's nothing in descriptor set 0, but we're still trying to set it or something. So basically that's where we're at. We have to figure out why that's happening. And I'm not entirely sure why. So the thing that actually, yeah, so if we go back to, that's us trying to do the render geometry, right? You can see we're actually setting the graphics state here. So in the graphic state, we have, oh wow, this is big. Does this scale now? Oh my goodness. Does it actually? Oh my goodness. This is amazing. In this new version of Visual Studio, this stuff scales with the text. That's incredible. Look at it. That's going to be so useful for videos, because usually I zoom in a lot. So there's like, you know, when I'm making content, people can see what I'm doing. But then this stuff was always so small. Now it's like big. That's awesome. I'm actually very, very happy. Okay. So inside the graphics state, as you can see, now I don't have to like, you know, try and zoom in like this. Yeah, so we should have our binding sets here, our bindings. So you can see we only have one. We have it in index 0, but it's set to something here that has a binding of size 1. And then that would be our constant buffer, so our uniform buffer, right? In B0 here, which we might need to change up a little bit, because I think it'll try and bind it at an offset of 128, or actually no, 384, I think, or something like that. I don't know. Anyway, so maybe we need to set something in binding set. Sorry, because I don't know, like if in these bindings, maybe the index corresponds to the set as well. So we have one binding in 0, maybe it thinks. And so it's trying to get to 1, but there is no 1, and that's what's making it crash. Maybe. So if we go to like begin render pass, maybe one thing we can do is, because I think we look at the graphic state bindings, and then we just push back this, which this immediately is not going to be, yeah. So maybe what we should do is, if we get the binding sets from here, let's go back to here. Because I'm thinking, I don't know, what if we just give it an empty array? Because I'm pretty sure, like these bindings, right? It's a binding set vector. Yeah, well, we don't even need to give it an empty array, right? We can just give it a binding set pointer that's what, null. Or just a binding, maybe a binding set that has no bindings. Would that make sense? Push back binding sets. Get binding sets. Binding set handle. How do we make one of these? We actually do device create binding set. What if we did device create binding set, but with a description of no handles? Oh, sorry, no bindings. Nice spelling. I don't know if that would work. At this point, I'm not sure. I guess we could try and just give it null for now, but I don't think that will work because I'm pretty sure I tried that. Yeah, so for example, you can see 0, 1, 2 is the binding set vector. So this also, isn't this also a binding set vector? Yeah, so wouldn't you just do, like, what if we just try to do this? Well, that doesn't work. Oh, well, yeah, we have to store it slightly differently here. But maybe this could be, maybe this could be a binding set vector. Because what is a binding set vector? Oh, it's a static vector, that's why. Yeah. I guess I can do that. We can do this instead, I think. And that's just gonna make it a bit better. Both from a memory perspective and also from a... and from an API point of view, because we'll be able to do this. So now that should work, and this I think should still work. So let's turn this off. But the issue with this though is that when we do this, we are gonna get empty stuff. So for that other render pass, it was both 0 and 1 were empty and 2 was had something in there, but I don't know what render pass that was. There may have been like the pre-depth pass actually, or something. I don't know, because I think we're still doing that stuff. Okay, so I think this also needs to be a binding set vector. No, the font that I'm using is just like Cascadia code or Cascadia mono. I think they're like the same. Which is, I think, the default Visual Studio font. I quite like that font though. Cascadia code. Yeah, I don't know what the difference between Cascadia code and Cascadia mono is. I think they're the same. See, this Cascadia code and a Cascadia mono like looks the same. So I don't know what the difference is. Maybe code has like ligatures or something. Yeah, that's what I was thinking as well. The ligatures situation. Alright, anyway. Did this run? Oh no, or did it not compile? Oh, we're running now. I think a lot of code fonts or like programming fonts have those ligatures. Yeah, so for example, this binding sets, you can see they're both null, and then we've got something here. But I don't know if that's going to be appropriate. What is this render pass though? Let's have a quick look. It's probably, I think it's probably like pre-depth. Yeah, it is pre-depth. All right, cool. So if I just let this run, okay. So it's upset because this, yeah, I mean, the whole binding set's null pointer, right? But why didn't it return, actually? What happened here? Why is the description null pointer? The actual binding set should probably be null pointer. Bindings. Yeah, look. What? So these are both null, as you can see. Or is it 2 that has nothing? Yeah, that 2 is very dodgy. Now what did I do? I copied the vector, right? I'm thinking maybe I didn't copy the vector properly. It's a static vector though, so can I copy it like this? That's the question. Let's see if there's a copy constructor. I mean, I'm assuming that it should work, or an assignment operator. Or is there none? That's weird. What? There's nothing here for that. That's really weird. So what did it do though? Oh, actually, sorry. It's a subclass of array. So that should have worked, right? That's really weird. Let's try this again. Because this would be quite convenient if I can get this to work. It's just clean, you know. Okay, so we copy this. So now we got this. That did not copy. Oh, actually, that's not here either. What? Okay, this is odd. So we have what frame index is 0, and we have that should be okay. I mean, obviously it seems like it's actually, oh no, that's what? Okay, something weird's going on. No, well that's wrong. That's correct. And that's correct. So just 0 is so frame 0 is wrong. Okay, that's peculiar. I don't know if we should be doing this stuff. So bake happens like once. Dot size less than 1. We in place back enough. We'll go through set. We clear each set. Yeah, now resize and all of that stuff doesn't. Oh, does it have to happen? Yeah, it initializes each one. And then is the idea that you can just use it. Yeah, you can just use it. And then it should go through each frame index and create it. Right? That's each set. Now, I will say it's a bit weird that, oh, well, yeah, this is very weird. Why are we going through it this way? Why is set on the outside and frame index is on the inside? Shouldn't it be the other way around? The reason why is because it means for every set we do this. I mean, this is only going to apply the first time anyway, but it still seems a bit weird. And I guess it technically doesn't matter here, but it feels a little bit unintuitive. I mean, it seems like it should work, right? Like, in place back. We don't need to do in place back though. We could just resize. And the thing is that happens. Oh, right. It's well, yeah, it's resizing the outer one. But why would you size less than 1? Wouldn't you just do this every time? Because you might rebake. So wouldn't it be better to do something like, well, you don't even probably have to do that. Wouldn't you just do this? Why do I have this weirdo going on here? Maybe before it made more sense. And then this goes through and just makes sure that you clear every set. So we're resetting it to a blank vector, blank static vector. Alright, yeah, I don't think we need this, but we'll see. Either way, I don't really understand why it's coming up with nothing, like with 0 being weird. Because this should produce the right thing. Let's try that again. It's very weird. Yeah, so the issue is that this is all DDDD. Yeah, and DDDD means that it was deleted, right? So somehow it's been deleted or something. But it exists in... Oh, this is also wrong now. Oh, they're all wrong now. That wasn't the case before. That's so strange. I mean, what is this? Like, what... I wonder what I've done. Pre-depth transparent. So that would have gotten baked and everything, right? There's no way that didn't get baked. Actually, let's make sure it did. I mean, I'm sure it probably did, but actually, yeah, let's make sure that it did. But it does. It should have, because the size is 3. It's just I did remove some stuff from there, but I don't think it was the pre-depth transparent, which is this, right? So that's the pipeline. And then, so that's the pipeline spec. Pre-depth transparent pipeline, which we use over here. Yeah, so we do the validate, we do the bake, we set the input to big camera, and that's pretty much it. And then we've done the baking. They're all static vectors as well. Like they don't, you know, the memory doesn't move around. So assuming this happened, I mean, we can probably put a breakpoint in and make sure that actually does happen. So if I do, let's just look at validate as well. Although bake is, I'm more interested in bake. Validate just makes sure the inputs are there. Yeah, let's just put a breakpoint here. Okay, we do hit that. Frame index 0 set 2, which is correct. We create a binding set. Here's our little set description. Yeah. Okay, so we have one now. So what happens next? Now we're on frame index 1, so we resize that. And I'm guessing we land back here. Then we're on frame index 2, and then we should also land back here. So now we should have all of this stuff set. But it's DDDD. Why? How are they? Oh, hold on a minute. How are they being stored? Oh. Oh, that's so annoying. Yeah, essentially they're weak pointers. So I just did a very subtle change, and I didn't quite pick up on what happened. But I used to store them as, so this was a static vector of, well, it wasn't a static vector. It was actually a standard vector and a city vector. But I was not storing binding set pointer. I was storing binding set handle. And there's a distinction because a binding set handle is a ref counted pointer of binding set. So it's a strong reference. Whereas apparently the binding set vector or whatever, that stores weak references, and that's obviously an important distinction. So it's fine to have weak references everywhere else. That's fine. I can still return a binding set vector, but I have to make sure that I store not a binding set vector, but actually the handles. Otherwise, yes, it will get deleted immediately. So C max binding, max like whatever layouts is what I'll store, which I think is 8 actually. Okay. Here we have 32. So we'll store this instead. And that should fix everything. So if we go back to the script set manager, so we just need to do the conversion. So when it asks for a binding set vector, then we can create one for it of weak references. And it's all stats. This is not memory allocation or anything. It's just a stack vector, so it's fine to do that. So where is this function? It's just we have to not make it a const reference. Now, how do I best... I guess I just... Can I set that up with the right size immediately? Like, can I just do that? I wonder if there's any other parameters, because so this is a static vector, but and to initialize the list, it is an SCD array though. There's probably an insert function, right? No. I guess we just do this the old-fashioned way. But what set? Set I. I think we just do this, right? Yeah, we'll probably hit that breakpoint now. Just want to make sure this does what I think it does. So we're frame index 0. Binding set size is 3. So result size should be 3, and then we're just gonna go in and frame index and yeah, okay, that should there's a bit of a blunder here because I think this asks it from this, and this actually should be returning not a const reference. Okay. All right, cool. Now let's have a look and make sure that this is now our memory situation is sorted, and we're not trying to access deleted memory. Okay. Yeah, that's a lot better. Cool. All right, let's see what happens. Okay, we still get a binding was null pointer. When we try and render geometry. Now, so the graphic state, let's just check the bindings in the graphic state. So there's two. There is one that's null now at index 0, but then there's one that's not, and that's the one that should be used. That's got a constant buffer. So now I wonder, I don't know, could it be upset at that one because it's null? I don't really know though. I don't really know what it means by binding was null pointer. I mean, it could mean that one. But what, does it want me to create an empty one for it? That's also possible. Because that's Vulkan telling it. I guess we could look up, because this isn't NVRHI, this is actually Vulkan. So we can, so we can actually have a look at what we used to do in those situations in old Hazel, because I'm pretty sure that it's also going to just probably depend on the pipeline layout and everything, but again, yeah, that might be worth looking at. So, oops. So the pipeline, how does it set binding? Get all descriptor set layouts, right? What happens if there's nothing there? I want to quickly check render geometry, and this is back in when Hazel used Vulkan directly. So I just want to see what we do with the descriptor sets. Yeah, see, we only bind it if it even exists, which it might not if there's nothing in descriptor set 0. And then the other, like begin render pass would have been not old. Begin render pass would have been the other thing that bound the other descriptors, right? Yeah, so you can see that if it has descriptor sets or whatever, it's gonna go through. Prepare. Do we run prepare? Maybe should already have one though. But that's a good point. We'll investigate that in a minute. But bind descriptor sets, and then that will obviously go from. See, get first set index. So that would be from at least 1, if not 2. And then, according to this, in render geometry, we bind descriptor. We just don't do it at all. So, and then you can see this is a descriptor at first set. So you can actually start your first set at 1, like we do, and then just never do this, and it won't complain. So it should be okay. Like, as in, it's definitely possible from Vulkan's point of view. Now, what happens here? So we have 2 binding layouts. I don't know what this even is, though. Like, what shader is this, you know? It's, Render 2D quad. So that has a texture. Okay, so we're actually kind of close. Render 2D line. Beautiful. We only had to run this twice to get to there. That's good, because there's a billion pipelines. So if we have a look at the binding layouts here, so there are still 2. So it does actually make 2. And it says there's a binding here. Oh, push constants. Well, sure, but that's not a real thing. And then the second one is going to be that constant buffer, which is the uniform buffer, right? Bindings, constant buffer. So yeah, so the next thing that I'm interested in is if I then, after setting that inside the renderer in begin render pass, right? If I then tell it to commit the graphic state, meaning basically bind, I think this will bind the descriptor sets. Bind pipeline. Where does it do the descriptor set stuff? I'm assuming it's somewhere here. There it is. Bind binding sets. 001. I don't know what random pass is. This is a pre-depth pass. Oh yeah, and it wasn't complaining about that, right? So what so it's gonna go through the number of descriptor sets, and then I'm guessing if it's well, yeah, binding set handle is null. I see if it's null, then it's fine. It just doesn't do that, I guess. How would it add stuff to that? So yeah, so it's fine, I think. And then when we actually have a descriptor, it will jump into this branch. And I think this should actually bind it somewhere. Or maybe it does it here or something. Yeah, see there's one descriptor set to bind. And then yeah, and you can see the first set is 2. So that's correct. That's exactly what we were doing before. And I'm assuming it does the same thing. I mean, we can keep checking, I guess. I guess I should. So let me put a breakpoint here. And for now at least. And then I guess we'll go back to begin render pass. And we kind of have to wait until we find the right thing, which is a bit annoying. So what render pass is this? I should probably make like a navviz thing, so it's easier to see. I'll bring it up here. Debug name nothing, really. Why do these not have debug names? Usually render passes do. They should all have debug names. No, and then we get to this skip binding. That's so strange. Yeah, so anyway, so that's definitely fine. So then this must be a different problem. Maybe well... And I believe the only thing that's doing render geometry at the moment is that thing. Now, the other problem is that it says slot 0. Yeah, so it might just be that actually. But remember, it's supposed to be like 380 whatever. So if that's even true. So where was that? Vulkan resource bindings, right? So I think I don't know if we actually reached this, but that thing with the, what is it, register offset, which is, so what's this function? Create, that it does that when you create the binding set. Well, yeah, I guess because it does the, yeah. So since we do it here, would that not mean that we are at an offset of like 300 or whatever? Yeah, we're at 256. So it's going to generate a right descriptor for 256. Okay, well, let's try this. Let's just try and be like, okay, you're at 256. I don't know. But I'm not sure that that would be giving us binding equals null, would it? Or maybe it's looking for something at that slot and it's not provided, therefore it's null. I don't really know. I'm a little bit lost, to be honest. Yeah, so still binding was null pointer. Binding was, I guess I can Google this because the Vulkan thing. Binding was null pointer. Binding was null pointer. It doesn't really say anything. Binding. What is binding? What is it referring to? And as usual, there's no validation, just this. Trying to draw 6 indices. Push constants we did. Yeah, I mean, like, again, the only thing that I can think of is the fact that in the bindings we have something null here, but and the difference is there's actually a draw call here, whereas there wasn't one probably for the pre-depth pass. But again, it skips this. And then as for the actual binding set, like, does this contain a unit? Look, here's an actual Vulkan buffer. It has an actual concrete buffer with, looks like a valid address and you know, it's got like a size of 64 and it's, you know, here's the buffer handle, which looks legit. It's got everything, so why would it be null? So this is where it's happening. So we're doing a begin render pass. Render geometry and end render pass, which all gets queued up to happen on the render thread / in this case deferred until the end of the frame. Well, this is a little dodgy. We're still doing const auto reference, but that shouldn't. I don't think that will. I think that probably still was fine. And I think we saw that. Like, the thing is, the other way it must just be expecting something to be there, but it's not, because the other thing is if it was actually accessing that null one, I'm sure that when we tried to bind descriptor sets null, it would have triggered there, you know, but this is on the draw call. Binding was null pointer on the draw call. Like, I don't understand where this is even coming from. Index count 6. Like, and this is from Vulkan. This is the Vulkan SDK. But also, why am I not getting any messages? Like, the validation has been really lax for some reason. Maybe I need to set some higher version of it or something, but yeah, like we're just getting one. Wait, so validation's on because we're getting one message up here, which is not that big of a deal and it's unrelated, but we're not getting anything else. And instead it's just crashing in here. So update pipeline state, update draw state, and this is all inside the validation layer. And skip binding gets us to binding is null pointer. So this binding that's coming in might be null. How strange. I think I have to go through this again. But from here probably. And just see what it ends up with. So here's another thing. Can I bind a descriptor at 2 without binding 0 and 1? Oh, but this is set 1 binding 0. I want to bind this set. And it says what? Invalid object 0. Okay, so your pipeline has set 0 even if the shaders never use it. It's still there. Right. So you can apply descriptor set 0 with an empty descriptor set layout. So bind descriptor sets. But isn't this a start set of 1? A first set of 1? Set layout count 2. Empty layout. But that's a layout. That's different. Because I think we do that as well, or maybe. But when you bind it, you just bind a single one. See? So you don't need to bind one. You just need to make sure it's in the descriptor set layout. Which it probably is, right? Because I think the pipeline creates that. And get all descriptor set layouts. I mean, it kind of wants to not create one though. Maybe it's not. Maybe it doesn't exist in here and that's why. I guess we can have another look at this. But it's got, the thing is it's got one anyway because of that push constant thing. So there's actually 2 binding layouts, which is descriptor set layout. So that's odd. I guess we could get the render pass to just have a blank one for 0. Or for any other one. That's a bit weird though. Like, I don't know. We'll try that if this doesn't... If I don't figure out anything better in the meantime. Oh, this just returns this. Which we already know had, in this case, 2. Push constants on a texture, but then the next one, which was our line, I believe, also had 2 anyway. Because it's got push constants. And this has a constant buffer. Okay, sure. Let's try something. It's a bit weird though still, but let's do this anyway. Because the thing is, this will start from 1 though. This is kind of annoying. This is just a little test. So the binding layout, we will grab from here for set 0, and the binding set description will basically be nothing. Like as in, I don't think we'll push back any bindings. I mean, we maybe need push constants or something. I don't know though. Let's just do this. So let's have a look at if we hit this. I mean, I'm assuming. So we're kind of just, we're providing now something in 0. And we should see the other side of this here. When we do bindings now, it should be there. A blank binding set might be worse than the null pointer. Well, we'll see. Yeah, so we are hitting this. Is that gonna work? Well, yeah, it didn't give us any issues. So let's see in the draw call now what happens. Or like, let's see in begin render pass what happens. Oh, okay. Bake. Oh, it's a compute pass. It might be a compute pass with no resources. Yeah, so now, oh, okay. Yeah, so anyway, we'll see if it works for our case, but you can see I only made it happen for 0, which is why in 1, it's still, null. But, 2 is the one that's actually legit, has a binding. As you can see, its binding size is 0, though. So it's wrong for this render pass, but, because we left 1 as null, but for our other one, it should be fine. Yeah, so see, like for this one, it's fine. We have like 5 for this. What is this? A lot of stuff here. What render pass is this? I'm just curious. Oh, the scene composite. Yeah, that's got a bunch of stuff. And then this is also 2. And then, yeah, 1. So this is probably our Uniform buffer, cool. So does that, still binding was null pointer. Ugh. What is your problem? Binding was null pointer. But the thing is, this is from coming from Vulkan itself as well. And with no validation. Binding was null pointer. Oh. Binding was null pointer. And it's trying to skip update draw state, skip binding. I'm just looking at the call stack and can see this like validation stuff that's running that's actually causing this. So it's, we do command draw index, post call record command draw, update draw command, update pipeline state, update draw state, skip binding. And it takes in a binding, and I'm assuming this binding that it takes in is the null pointer. Descriptor binding. Is there anything else? There can't be anything else in that shader. And that's definitely the right render geometry call, right? Like, as in, we're only ever doing, well, yeah, I think we know it's this because, well, actually, let's quickly look at the graphics state. We'll know if it says that it's a line. Triangle list. Oh, guys, this might have been a red herring. Triangle list? That's not our lines. Unless I did the lines. And come to think of it, 6 indices for a line. I mean, that could be 3 lines, but it also could be 2 triangles, aka a quad, which is very suspicious. But where else are we calling render geometry from? I can't believe this. This is so dumb. Let's have a look at where we're calling that from. We can't see it there because it's added to a render command queue. I thought the only place we were calling this function was in that line rendering, because the line rendering is what we're trying to get working first. But it must be happening elsewhere. Okay, so what's this? And I'm interested in how many our index count is. Okay, 6. Oh, but look, it's the quad pass. They're actually all doing it. Why did I assume? I think because we weren't supposed to be rendering quads. Oh. Okay. Well, yeah, I haven't set up anything for quads, so no wonder it's complaining that stuff's null. So let's just disable quads and text for now, the old-fashioned way. In fact, I'll just do an if to do. So quads and that, it's all disabled. Wait, why did lines also become disabled? Here's lines. That's weird. Are we doing lines twice? Because it's on top and not on top. Okay, sure. Okay, that's actually such a blunder. Okay, so in that case, let's remove this, because I don't think we actually needed this. So let me just comment that out for now. Okay, so now you can see we have 2 that are null, and then we have this one. And I think if I try again, so for, this is probably like the line pass or whatever, you can see it's, oh no, that's the other one. Oh, that's it. I think we're rendering now. Oh, that's the composite pass or something. So anyway, are we good now? Hey! Yeah, that's unbelievable. So it was the stupid, I was rendering something else that I didn't realize, and that's what was not working. So if we try and, I don't know why we're rendering lines at all now, but if I try show binding boxes, yeah, you can see now we're actually rendering lines. So that 6 that we saw before was quads, and it was probably like an icon or something, like a light icon in the viewport, you know? Okay, but look, it still crashes. And binding was null pointer. Okay, so, but now at least we know that where it's coming from, right? So now let's try and go back and maybe enable this, even though I am a bit suspicious about it. Okay. No. Still, binding was null pointer. So whenever we try to draw anything, it's upset at this now. And this has to be lines. And it's probably quite a lot. 2,000 verts. It's a lot of lines. What, like, you know. What could it be upset with? B256. That's definitely wrong, though. Okay, here's what I'm also thinking, guys. I'm thinking that actually this should be 0 in here, in the shader. Unless it's like an HLSL shader or something. I don't know. But this should be 0. Maybe. And then that offset may need to happen. What, in shader reflection? See, that doesn't make sense though. Okay, let's try it again with binding 0 and we'll just see what happens. I'm very confused as to what's going on with all of this binding offset garbage. No. This is very annoying. I just wish it would tell me more instead of just crashing. Should I try update Vulkan? Like, should I try and use a different Vulkan version maybe? Maybe it will give me more info. Maybe. Let me try, I don't know what I've got installed though. Let's try like, we're on a decently high version, but let's try like 4. Let's try a 1.4 version. This was released like 20 days ago. What could go wrong? 1.4 has been out for ages. Well, since the start of the year, basically. Okay. Oh, it's dark now, the installer. Nice. I wonder if this will tell us anything. Probably a waste of time. Let's do 1.4. We'll have to change it to a 1.4 version. All right, Q&A. Anything? Anyone have any questions while we install this Vulkan? I'm kind of annoyed at this whole issue at the moment. Oh, it's almost done. Oh. How is instancing working in the scene renderer? You place all the matrices in a vertex buffer? Yeah, exactly. Yeah, we have a big vertex buffer for all of the entity transforms, or all of the mesh transforms. And then we just yeah, read the transforms from there. Could probably use this. I don't know why exactly it's a vertex buffer. I don't remember why I did that. Like, I assume it could have been a storage buffer, but yeah, it's just the way it is, I guess. I don't know. I really don't remember why. I think because it makes. I think because it kind of works because you can do the instance offsets and the jumps between them. Like, it kind of makes a bit more sense because it handles it automatically, whereas with a storage buffer you'd need to be aware of what index your object that you were drawing was within the vertex buffer so you could get the right matrix or the right transforms. Okay, so is this now? Yeah, this. Cool. So we're now on a different Vulkan version. I don't know if this will help. Let's just try build. We might get some other validation errors, who knows. You're gonna host a game. Whoop, we are. Nice. What's wrong with you? Why is this stuff? Oh, I just need to exclude this stuff. I should just delete it, probably. I'll exclude it for now from build or from project. Oh. Great. We may have to rebuild. Oh, because that might still be using a different version, or would it be though? Are you going to host a game jam someday with your engine? Yes, once the engine gets released for free, which is the plan. So anyone can download it and make games with it. I'm going to, yeah, probably host a game jam. I want to see what, I mean, that includes that. What does it link with? Or it doesn't, because it's not it's a static library. Maybe we'll try to do a clean build. We might have to link something else though. Am I still loving the deving? Yeah, I mean, I guess so. If you work on stuff you enjoy, because the thing is, like, in my mind I'm building something, right? I'm building stuff, and building stuff's never going to get old. It's always fun to build things, right? That's kind of, it's not like the programming or the development that's necessarily like amazing, you know? It's, this is interesting. It's the concept that I'm actually building something, and programming is just like a way to, obviously, that's the tool that you use to build this thing. But I'm more excited in the thing that I'm building, not the tools. Okay, so what's your problem? Dynamic loader, is that not a thing anymore? Great. It's in detail now? Okay. They just moved it to a different namespace, apparently. Well, why would I debug Hazel with Ghidra? That doesn't make sense. You saw games from scratch, new video about Hazel. Well, yeah, I saw the video. Yeah, I saw the video he made like shortly after I made the video saying it's gonna be free. Ghidra can build to assembly, which is easier to debug than this. Yeah, definitely. Okay, that's it, apparently. Let's try run this. I don't know what will happen here. Like, as in, I don't know if we'll get any additional validation warnings. Probably not. Which is upsetting. What? That just didn't crash. But I don't see any lines. Is it rendering? You gotta be kidding me. How do I know if we're rendering? Renderer. What a joke. Okay, well, we are rendering. I'm not seeing anything. I bet I'm not seeing anything because we do have to have that offset. What was it? Like 256? Was that right? That's a joke. So what? It was not working in that version of Vulkan. Nice, but how you decide which meshes, submeshes are instanced? Everything is instanced. So Hazel basically instances everything, because Vulkan is set up in a way that you always, like, you can always use instance rendering. You just render one instance and that's it. And the entire scene's transforms are in that vertex buffer that's accessible in all the drawers. So they're just already stored there. So it's, yeah, you don't have to have like a, is this instance, is this not? If it's just it's just always instanced, and you either draw one if you're just drawing a single instance, or you draw 10 or 100 or 1,000 if there's many instances of that exact geometry. And that's kind of it. Okay, well, I still don't see lines anywhere. We should see lines, by the way. That's kind of what, whoa, that's not a line. We should see lines in the viewport, supposedly. That's what I'm going for. So if we can do that today, I'm gonna be happy. If not, then c'est la vie. When will Hazel be out for free? I don't know. When it's finished. Which might be like a year from now. Hopefully first half of next year, but we'll see. How do you handle skinned meshes? That's a whole video. I've got, I made a video about animation in Hazel. Well, it's more of a high level, like, user experience of it, but That's a thing. If you just search for animation Hazel on YouTube, you'll probably find the video. Yeah, so we have the camera. Yeah, I'm still a bit confused with all these binding points. So constant buffer does have a 256 apparently. Yeah, because I mean I could just ignore, if I really wanted to see it, I could ignore it, but don't really want to. We're definitely drawing lines, right? Okay, I think it's time to boot up RenderDoc, and we'll just see if that uniform buffer data is getting to the thing. I guess we can do a release build, I think, now, because otherwise it's gonna be it's faster significantly to run release than debug. I guess what I meant is, how do you decide that a specific geometry needs multiple instances? Well, that's kind of like, if it's the same asset, then if it's the same mesh asset, then it just automatically gets instanced, because you're trying to, when the draw list gets created, like by the scene for the scene renderer, it is just like, oh hey, all of these entities are using this mesh. So therefore, it's like the mesh asset handle is used as like a key, I guess, in a map or something. I don't remember the exact implementation. But therefore, it knows that like, oh, you're submitting a mesh that has already been submitted before. Like as in, because I'm adding it to that key, to that bucket in the map. So therefore, just draw another instance of it with this transform. And that's kind of how it works. But everything flows through that system, so that it like, so there's no like early detection of like, oh, are there multiple versions of this in the scene? It's just always like, how many of this is there in the scene? Or like, I'm submitting it and it will just go into the right bucket or whatever. And you update the vertex buffer with matrices every frame? Yes. So that vertex buffer gets, because our the objects we draw change every frame. So therefore, or can change every frame. So therefore, yeah, we restream all the data every frame. We really shouldn't for like probably static geometry and other things, but we do. I'm not saying it's correct, I'm just saying that's what we do. Okay, so yeah, so we should be drawing lines. Okay, good. So let's run this, I guess, through RenderDoc, and then we'll see if we can so if we go show bounding boxes, and for not just the selected entity, that should be correct. So we should be able to see, this is still annoying, it's a whole undefined thing. We've got to work that out. But so here's something that's clear, and then we have clear depth stencil, begin render pass. What's this? Some label, apparently, and render pass. Oh yeah, sorry, we'll do it later. Is this it or something? That's also some I guess I can just look at the drawer or something. Might happen later. I'm not exactly sure when it happens. Oh, here are the lines. Yeah, it is a bit suspicious that it's drawing. Probably need to make sure it's in the right layout. Even though Vulkan, I don't know why it's showing up as undefined here. Vulkan validation seems fine with it, but it's probably in the wrong layout or something. So yeah, that's a bit weird. Buffer 1. Texture. So where's the actual? So this must be it, right? Pipeline state, vertex input. Buffers 0 and 1, no resource. Byte length. What the heck's that buffer? Primitive topology is line list, which is, I guess, correct. Yes, it is a list of lines. What was I gonna check? So this whole having a slot in that buffer, having buffer 1 or something is a bit weird, right? I mean, I think we just have 1. Because instance layout and bone influence layout probably not a thing. Yeah, because it's only if those, I guess, exist. Do we make attributes for it? And buffer index plus plus. Whoa, hang on a minute. Is that correct? This seems like it might be wrong. Because why would it be incrementing? Shouldn't buffer index be outside here per buffer? Let's have a look at... That's the wrong one. Let's have a look at old Hazel. Where are the buffers? Here it is. Yeah, see, it's binding plus plus is outside of this, and location is plus plus inside of this. So binding plus plus is apparently the binding, but either way, it probably shouldn't be buffer plus plus here, right? Because I'm sure buffer index is the actual buffer index, right? I think something like that is probably better, because otherwise it does seem to think there's another buffer there, which shouldn't be. So I think that will fix this situation, because otherwise it's literally making a buffer for each thing. I don't know if that's going to make it render, but that's definitely a fix that needs to happen. Now the fragment shader doesn't have any uniform buffers though. How does that make sense? It has to. That's very strange. Okay, I'm gonna quickly say goodnight. I'll be right back. Hopefully it works. The show is continuing on without me. Let's quickly just check this, just in case. Yeah, still no line. Okay, I will BRB. Yeah, still no lines. Yeah, but again, we're just trying to debug this one step at a time. So let's try and launch this again. Now we'll hopefully get that extra buffer away and disappearing. And then the other thing I wanted to do was make sure that we have our viewport in the right layout, which, I mean, probably shouldn't affect rendering, but might. Which is why I want to make sure that we get it in the right layout. Okay, so here are all of our lines, I think. Oh, well, actually, no, this is GUI stuff, isn't it? Yeah, this is GUI stuff. Our line stuff should happen before that. We can actually filter by draw here. So, oh, we're not drawing any lines. Oh, it might be here. Yeah, it is here. Okay, so this is the line stuff. So pipeline state, vertex shader. Okay, so now vertex input, you can see it's gone now. So we've gotten rid of that ridiculous buffer. Here's our line buffer, which looks fine, I guess. That looks plausible. What I'm confused about is the fact that we have nothing here. Like, we don't have uniform buffers here at all, whereas we clearly should. So I'm not sure if that's the case because I set this to 256 and it's just like, what are you doing? Let's try setting that back to 0. And then if I rerun this, we'll just see if that works. And then the next thing we'll do is this whole undefined situation. We'll fix that up as well. That's kind of what I'm thinking at the moment. Yeah, we're still not seeing it. That's so strange. Why are we not seeing it? We could try nSite as well, but... Oh, wait. Because it's not... I'm an idiot. Because it's not in our fragment shader. It's in our vertex shader. Oh, yeah, but this is interesting. Is it correct? Well, this is just an identity matrix buffer. Huh. Which is not invalid memory, right? So maybe it's fine at binding 0, but it's just we're not setting it properly. But begin scene sets it, does it not? Look, uniform buffer set, yeah, so it sets it to this. Begin scene is supposed to do RT set data to view projection, which comes in from begin scene. Which all of that should, like the data here should probably be correct. Let's switch to debug and we'll just validate all of this. But I'm assuming that's correct. But yeah, obviously identity is not correct, but it's also not like, you know, random data or unset or whatever. Like identity is obviously, I feel like someone's gone in and set that. So, we'll see. What is the compatibility type for 3D models, says Dave. Will Hazel support the same compatibility as Godot with Blender? It will be possible to save and make changes, and will animations and textures be imported automatically? Well, yeah, I mean, we kind of support GLTF and FBX, so to speak. We use Asimp for our importer for meshes, so anything really that Asimp supports, theoretically Hazel could support, although they all have their particular things that might need to change. And then we have our own runtime format, like for the runtime, for meshes. But we, yeah, I don't know what you mean by save and make changes. I mean, you can, what happens is because in the editor, when you're making a game in the editor, Hazel always uses that intermediate format rather than the published kind of format. So in other words, it always sources its vertex data and, well, mesh data from the GLTF or the FBX, not from its own format until you build for the runtime. So because of that, you can actually keep working in Blender, adjust like a vertex or a material or whatever it is that you want. And then if you re-export that GLTF or FBX or whatever, then it'll actually be picked up by Hazel's background asset thread automatically. So within like a second, it will just reload in your viewport, which makes iteration really nice. And I don't know if that's what you meant by save and make changes. And animations and textures do get imported kind of automatically. You have to import them though. I can show you quickly here. I'll have to compile that anyway, but let's while that's building, let's do this. I'll show you in a different version of Hazel where stuff actually works. So yeah, so view projections obviously look. So you can see that like the values here are kind of like minus 0.96, right? That's what I expect to see here, but it's just identity. So we're gonna try and track down why that's happening, considering this seems to be working. So let's actually go, we'll do step into specific. And we'll go straight to RT get, or maybe RT set data, which, because I guess I should validate this stuff. So now we're here. We've got a buffer which should have all the data there. We've got an offset of 0, and we're actually writing it in. So it kind of looks like it is working, but I'm not seeing the data in the shader. And that is set as an input. But why is it like 1? Okay, so this is a working version of Hazel. So if I go into meshes, for example, oh, it's regenerating stuff. So here's like, you know, here's the female character. So if I drag her in, oh, so that's already a static mesh. Let's go to source characters. So here's like, ignore the thumbnails being weird, but here's like, you know, the female animated character, but this is a mesh source. So you can see this is an actual GLB. So if I basically try and import this, it's gonna ask me what I want to import, and there's quite a lot of different things. So either I want to create a static or a dynamic mesh. Usually you can do both, but there'll be different assets. The skeleton now is actually, I think, part of the dynamic mesh. So it's a bit different now. And then these are all animations. So normally you'd be like, I want a dynamic mesh, which will come with its materials and stuff. And then if you want certain animations that are inside that file, you can pick and choose what you want. They'll be separate assets basically. And you can retarget them using Hazel, I think the newest version of Hazel, like not 2024.1, but the in-dev version, I guess. You can retarget those animations to any skeleton. So that's kind of how the mesh importing stuff works. And because it's still going to reference that GLB, so if you make changes to it, you'll see them, like, you know, in the actual viewport. All right. Yeah, I'm a little bit confused as to why we are not seeing this on the GPU. And why we're seeing identity? Like, that's... Who is setting that? That doesn't make sense. Wait. This says push constants. What? What do you mean push constants? That's a uniform buffer. Oh, hold your horses. So that's wrong. That is wrong. Because it's all, yeah, so this is it. This is the thing that's identity. And then this, it's not actually seeing, apparently. Like, as in, it's not here at all. It's under uniform buffers, but it's the push constant buffer. So why do we not see the uniform buffer? That's kind of weird. Like, as in, that should be in the pipeline layout or whatever, right? And I thought I saw it there. Like as in when we did this, get all descriptor set layouts. These are the shader handles, but binding layouts. That's really weird. Because I think that even if we didn't set it correctly, if we defined it in the layout, I think it should appear here. It will just be red, like what you saw before with the buffers, how we had a red buffer in slot 1 or whatever. We're gonna have to find that render a 2D line thing, because this is, what is this? 2D quad. Okay, render a 2D line. So this is it. And yeah, we've got two binding layouts. 0, which is that push constant one. Yeah, push constants. That's what we see in RenderDoc. But then we've got a 1, which is our constant buffer. So why on earth do we not see that? And then yeah, we have these weird binding offsets. But the point is, our binding layouts are actually here. So let's go to, that's the input layout. So binding layouts is in the pipeline description. So I'm guessing when we go to create graphics pipeline, let's jump in here. So much stuff. Where's like the descriptor set layout stuff? What's it even called? Guess I can just have a look at what it does with the binding sets. Oh, here it is. Create pipeline layout with create binding layouts, or like this binding layout vector, apparently. Descriptor set layouts. Even does empty descriptor sets. Yeah, it's a very weird. I mean, descriptor set index layout get description register space. Right. Yeah, we can keep that as false, I think. Yeah, and see, this is more for HLSL to spare V, I think. I don't know if it affects GL, because we had to do that in HLSL to get it to work, but in GLSL, I don't think we do, apparently. But I don't know, I might have to go through this and make sure it actually works. because it's a little hard to read as is. But we are inside correct graphics pipeline, so I can actually just jump to here, right? So here are our two binding layouts. So this is just the push constants. Yeah, so we basically end up doing this whole out binding layouts thing. And so we have two now, which we also did before. There's our constant buffer. And then we just push it there. Let's push constants, we do that. Otherwise, it's not a push constant. Well, yeah, we've still got two descriptor set layouts, one for each descriptor set. So what the heck happens to the second one? Do you have support for both HLSL and GLSL? Yes. One of the reasons we do that is because people might want to write shaders in whatever language they want, but also because we use some third-party like shaders that are written in HLSL, for example. So rather than like port them to GLSL and then not be able, like the divergence would be difficult to manage, we just support HLSL. But again, we might support Slang or something. I don't know. See, that's the thing, like, you know, supporting something like Slang or Slang or whatever, like one of the issues would be rewriting all of our shaders. Like, it would be nice to support that as an optional thing, but to mandate that would be a bit difficult because it's like, well, some of the shaders we use, you know, are third party, for example. We didn't write them, and we're definitely not going to port them to Slang. That would be stupid. So therefore, we would need to support both anyway. It could potentially make our shaders easier, though. So all of the actual Hazel shaders, sure. But we can't just not support HLSL, for example, because certain shaders are only provided in HLSL. And also HLSL is kind of industry standard. Like GLSL is not used that much in the industry, especially not for like desktop / console games. Maybe for mobile it is. I think we used to use it for mobile. No, well actually we had our own shading language. And it was, I remember on Osiris, like we actually wrote shaders in C++. And then, so you'd write shaders in C++ code a lot of the time. And then it would actually build them into like GLSL or into SPERV from that. And that enabled us to do some cool kind of, you know, permutations and whatever. So, yeah. Anyway, this is bizarre. Like, I don't know why on earth it's not showing up here. I guess I should try Nsight as well. Maybe that will give me some insight. See what I did there? Into what's going on. That's already set up. Um, yeah, I don't know, man. Like this uniform buffer is just nowhere to be found. Like, what is going on? Like, it's not just not here. We've got this push constant, which we know, but it's just not here. That's so strange. Now, are we still, where did we land on that whole, if we have empty things or not? Okay, we did put empty things in. And that was necessary? Let's try disable this. It's not used and optimized away. No, it's definitely used. It's used right here for the output position. It's not gonna build. Is it running? Oh, because we're in debug. So is this gonna crash now? No. Okay. Well, interestingly, it also didn't crash like this. Even though we're not doing that thing anymore. But I don't know, like, yeah, something must be really weird going on with our things that we're binding. But again, I would expect, let's rebuild release and then we'll try it in RenderDoc. RenderDoc's a bit easier to work with. Yeah, it's just not here. Like, what? How is that going on? Okay, so, yeah, so descriptor sets that are bound. So we've got nothing in slot 0, which is fine, I believe. And then here's descriptor, here's index 1. So this is descriptor set 1, which is supposed to have our uniform buffer, which we don't see. So what's going on here? Look, uniform buffer, shader mask, vertex, and pixel, byte offset, show contents. Oh. Well, can I view this as floats? Like, look, here's a uniform buffer, right? So how is it not showing up in here? But it's in the descriptor set. Index 256. Why is it still 256? Didn't I set that back to 0? Oh, well, yeah, see? It thinks it's in 256. So then, therefore, doesn't this have to be 256? But I already did that. I mean, let's try it again. This is bizarre. This whole offset thing is ludicrous. I could just remove it for a bit and see if that helps it. I didn't need to not show the grid. But yeah, it doesn't show up anyway. Oh, now it's 512. Oh, okay. I think we're getting somewhere. So yeah, well, yeah, because it always adds that amount on. So I think this is what's up. This has to be 0 here, but we, in the shader compiler probably, which generates the reflection data, needs to set this binding probably. This is probably what's up. Where are these stupid offsets? So it'll be offsets, constant buffer plus binding. I think that's what's up for uniform buffers. And then what else is in here though? That's constant buffers. Unordered access gets 384. So storage buffer needs to be binding unordered access plus that. And then what else are we dealing with? Samplers. Even though I kind of got that working. So separate samplers probably, which we are going to use now. Also needs to be offsets plus sampler. And then finally, for textures or whatever, we do sampled images or whatever. But it's set to 0. But because you can change it, I guess you can... is it set to texture? What is it? Shared resource. Yeah, so now this actually might work. D3D guy here, can you explain what that offset means? So basically NVRHI, because it tries to deal with Vulkan and DirectX 11 and 12, what they have done, which I don't necessarily agree with, but it's factual, that's just what they've done, is they have this like offset for Vulkan specifically to, I guess, make up for the fact that there are different registers or register types in HLSL and in DirectX. So, for example, the ImGUI shader, which is written in HLSL. Stop opening the wrong one. You can see that it's got like a sampler and a texture. Sampler's in S0, it registers, but the texture's in T0. They're both 0 as far as Vulkan's concerned, so that you can't have two things in one binding point. So what they do is they offset by type to make up for this letter, essentially. So this sampler actually shows up as binding 128. You don't have to do this if you're at GLSL because it's done automatically. But because this sampler, actually I need to change this I think now that I've added the offset in the actual in the shader compiler. But anyway, it makes up for these different types by having an offset that in Vulkan always gets added. So for example, when we have our generate write descriptor data for all these different types, instead of just, where is this stuff? Instead of just using the binding slot, it adds the register offset. This is NVRHI code. And that offset again is just get register offset for type, and it all just comes from here. It's like a little table of offsets. So I'm just also mirroring that behavior here. Otherwise we don't get our resources being set correctly. So now hopefully they are set correctly. But I'm not seeing lines. So let's go back here and maybe we'll see it now in here. I don't know. But yeah, that's basically the whole offsets thing. I'm displaying bounding boxes as just a way to render lines because I just figured I'd go with line rendering initially. Like we'll bring that back first because that's easy. Well, it's supposed to be easy. It's proving to not be easy and it was still not here. But in the descriptor set layout, we now have 256. We have this thing here. But why is it not showing up? And I guess this is the right, I don't know, like, how do I really wanted to see this. Are you not hitting register limits by doing this? I don't think so. And again, I'm not doing this. NVIDIA is doing this. So I trust that they know what they're doing. But maybe they don't. No, who knows? How do I want to view this as floats. Why is it not letting me? Oh, because it's format. Can I just write something in here? What do they use? I kind of forgot how they express that. Hey, I did it. Oh, look. This is plausible. Yeah, this is probably correct. It's just weird that it's not showing up here though. But at least now we know that it's being offset by 256 according to the descriptor set layout. But again, I can see the contents, but why am I not seeing it here? And now the bind point should be legit, I think. Like, as in now if I look at... hold on. Maybe it didn't work because I didn't clear my cache. Let's just clear the shader cache. And we'll rerun this and then I'll recapture it, I guess. Okay, so yeah, it should have regenerated. The reason why is because we changed the binding points there in the reflection. The code that generates the reflection data, so I just wanted to make sure that then that's fine. But yeah, we still don't see the uniform buffer here in the vertex shader. It's so strange, bro. Why is it not here? We just see the push constants. I mean, surely set 1 makes it, right? Should we try and re-enable this again and have an empty set? But I kind of thought it would tell us if something was wrong. Yeah, this hasn't been very helpful in terms of like validation and whatever else. Yeah, it's very strange. Could it be something in the descriptor set manager? And also start set and end set. Well, yeah, pipeline sets that to 1. Yeah, I mean, I don't think there's any point in trying this through RenderDoc now. I see nothing except for this uniform buffer, which is legit, but doesn't show up in my bound like thing. And like, look at this. This is all nans. It's probably all nans because, I mean, the input looks very sus as well, though. Look at this. Why is the input so sus? Look at this. The index, and everything's wrong here. What? I mean, I expect this to be nans because it's being multiplied with the thing, but why is this wrong? We've got like this vertex buffer, right? And look, it's fine. Well, that doesn't even make sense. What? Look, that's fine. Here's our color, here's our thing. So then why does... Here are our attributes. Oh, well, the index buffer is all messed up. Look at the index buffer. That's why. Okay, let's go fix that, I guess, maybe. Ah, this is so weird. Like, yeah, what's the deal with our index buffer should be like the simplest thing ever. That's very strange. Anyway, line index buffer, right? Max line indices. What is max line indices? Max lines times 2, which we have. Yeah, we've got 2,000 lines. That's why it keeps flushing. That's why this is limited to 2,000 indices per draw. So it's got the index count correct, but the indices are not correct. Okay, so yeah, so like you can see, it's just ascending from 0 to whatever. It's the simplest thing ever. Probably not even use an index buffer because you can just do probably draw arrays or whatever. But nevertheless, we have this thing here. We do index buffer create, allocation size is that. So this must not work or something. Index buffer create with a buffer. So let's have a look, because obviously this is somewhat new. Index buffer create with a buffer passes the buffer into this constructor, which allocates some size. It's an index buffer, keep initial state, is index buffer true, index buffer. Haven't really tested this code, obviously. It does it then and there. It immediately just writes the buffer and closes. I mean, this looks very normal. Set data is not implemented, but it doesn't really need to be. I mean, it does for this, but not for that, right? Because we create it straight away with the data. It actually does it twice as well. I'll put a breakpoint here, but this is not promising. Do we need anything else here? Is buffer size and stuff correct? I guess I should maybe have a look at this. But the buffer size should be correct. I'm in release. A little bit suspicious. That's so strange. It might not be this at all, might not be bound correctly. I don't really know, to be honest. It should be just bound using that render geometry call, I guess. Okay, so line indices, allocation size 8,000. I guess we can have a quick look at what line indices are. Set 2, so there they are. They're just ascending 0 to whatever. Let's do step into specific, and we'll go into index buffer create. No, actually that's the wrong one, but whatever. Oh, well, okay, let's go to this one. I guess, is it? Create that? No. Take me to the actual function, please. Here I am. Sure. So buffer size is 8,000. That's legit. 4 bytes per index, and there's 2,000 of them. And then we just write in all the buffer data, which, I mean, should be correct. Yeah. Yeah, I mean, what's up with that? That should be good. I can't really speak to that. It should be good. We created a buffer. We put some stuff in it. It's marked as an index buffer. What more do you want? So now when we render the lines though in end scene, I'm expecting it just says render with that. So here's the line rendering, render geometry. Line index buffer is what it takes in here, which is correct, right? This actually uses line on top. Oh, well, yeah, because we do both. But anyway, it's still line index buffer. I don't know why we need a separate one for line on top. But anyway, render geometry. Line path says line on top. We've got the vertex buffer here. Remember, the vertex buffer seems correct. So what could be going wrong with the index buffer? Offset 0. Oh, vertex buffer get handle. What a blunder. Oh, index buffer get handle. Damn. Okay, that was a typo. But that doesn't explain the uniform buffer not being here, right? I'm surprised. Why did that even work though? It should have been like, hey, your usage was marked as vertex buffer, not index buffer. So I don't know why that wasn't a validation thing. Okay, anyway, we're still not seeing lines, but let's have a look at... This is so weird though. The whole uniform buffer situation is very weird. And I think we'll have to leave it till next time because it's getting late, but... validation layers are enabled, and I know this because we get exactly one validation warning at the start. Actually, it's gone. It used to be here before we updated it. But it makes sense because remember we were getting a crash to do with binding layouts being, or the binding is null pointer. So I feel like we updated Vulkan and somehow now validation maybe is off, and maybe that's why we're not getting that crash anymore. So I think that's definitely the case because it makes sense. It's consistent with what we're seeing. Actually, I forgot to do this. So let's make sure we do this. So I think somehow in this new version of Vulkan, we just don't have validation rather than Vulkan, because the crash was coming from a validation command, from a validation layer thing. Yeah, so it's not here, even though we have this here. Hey, thank you, Izuki, I guess, for the sub. We have the uniform buffer and its contents are fine. So let's have a look at the vertex buffer then. Oh, sorry, not the index buffer, right? Here's the index buffer. Hey, there it is. Okay, so we fixed the index buffer issue. If we have a look at the mesh viewer, oh, look. Here's our geometry. We see all the bounding boxes for everything in the scene, apparently. Well, not everything, but some things. It's weird that it's like this. But whatever. Oh, because it's only one draw. That's why. Because it's all, it's limited to 2,000 indices per draw. So there's several of them, but that's the whole scene, basically. However, you can see the output is nan because we're multiplying with a non-existent uniform buffer. So this is good. This is better. Now at least this is drawing. But yeah, the whole uniform buffer issue is weird. Validation is weirder. Why are we not seeing any validation? It's definitely turned on. Unless there's like some new way to turn it on or whatever. But like, you know, this is all enable debug runtime. It says false here, but it's really true. Actually, let's just quickly check what this does. Guess we have to run it in debug. This will be quick though, because it happens before I think we do anything else really. Oh look, it is true, and it is inserting those things. Unless there's more things that need to happen. I mean, is that all we need to do? Like, make sure we have this it as an enabled extension, and that's it. Let's just open up the configurator. I don't know what version of the configurator this is. Yeah, okay. Let me just go to here. Because I think we can, I mean, newer version. I'm on that version. That's a bit weird. Okay, so can I force validation? I forgot how to do that. But let's try run it with this open, because I think sometimes that helps. Explicit, it says enable. But it's not showing me anything, is it? I don't know if this is gonna override this though. I forgot how to make that happen. Oh, it says any running. Oh, good. Look, we're getting validation errors. Amazing. Finally. So these are probably the overridden ones. But see, that's the thing. Why wasn't it there before? Why did it take me forcing this thing to happen? So what's the problem? This is fine that we used to be getting this one before. So scene renderer init. Uniform buffer was not declared in the pipeline layout. Look, stage vertex buffer. This is exactly our problem. Stage vertex. So the vertex shader uses descriptor set 1, binding. What's it going to say? 0. But it was not declared in the pipeline layout. Yeah, because it was declared as 256 probably. And look, it's renderer 2D. And then everything else I probably don't care too much about. Render, yeah, here it is, renderer 2D line. So it says it's set 1 binding 0. Probably because it should be 256 or something. With that stupid offset in mind. Really don't like that offset, this offset business. I don't know how I should be declaring everything here. And the thing is, if I use that offset, then it doubles up on it. Okay, good that we have the validation thing, but let's get rid of this whole offset business that I just added. Where even was it? This. Don't even know why it like. It really should probably only use that for either HLSL or something. Maybe it just expects all the shaders to be written in HLSL. So how would I make this work then? Oof. Let me try something. Let me do this. Let me just set constant buffer offset to 0. Now I can do this. I can do it this way. But where would I call that? Let's just do 0 here, even though it's going to recompile everything. And let's do a release build. Just wondering if this will work now. Yeah, it's probably not a good idea to affect the header. Okay, that built. Let's have a look at this, and I want to have a look at this through RenderDoc. Now that I've reduced that offset to 0, I feel like this will work. I don't know if this will work for DirectX though, but I don't see why it wouldn't work for Vulkan, right? Guys, I don't know why it's upside down, and I can't move the camera, but look, we did it. Ah. And just as the game engine series music comes in. That was epic. Oh. Now it's upside down, and for some reason I can't move the camera. Now fixing the camera movement should be possible. It's upside down as well because I think we're probably flipping the image twice, and it's not. I don't know why. I guess we can fix that quickly. So renderer begin render pass or something. Oh, we're not. Maybe we're not flipping it, and we should be. I must be. I think it's that actually, because we used to flip it here, right? No, maybe not. Ah, well, if it's a swap chain target, we flipped it. Otherwise, we didn't. So we probably shouldn't flip it. Well, how do we draw the image though in IMGUI? Probably in a fine way. I think we just draw the image, right? Oh, well, we do 1, 0 here, so we do actually flip it. So we don't need to flip it, I think, is basically the solution to the flipping. And then as far as the camera, why do we not move the camera? Because we should be doing edit a camera on update, right? I can't believe we did this, by the way. Totally thought we would only do this next time. The new renderer is really coming alive. Anyway, we should be doing edit a camera on update. So don't know why the camera's not moving. Yeah, there we go. So now it's the right way up. Oh, and also scrolling works. So events work, but not. Oh, why was this not working before? Look, guys, this is incredible. We actually did it. I actually think you could probably play the game like this. I don't know if hitting play works. Nah. Just crashed in physics, I think. Play does not work for whatever reason. I don't see how that's renderer related, but whatever. But look, actually look, I can't click right now, but if I gotta click in the viewport to focus it. That must be some weird thing. You didn't have to do that before, and now I think it's like, oh yeah, so now it doesn't work. So right clicking doesn't focus the viewport anymore. It used to be when you hover over the viewport it works, but now you have to click and then... But anyway, either way, look at this, guys. Isn't this exciting? Gizmos don't render, do they? I can still select stuff though. But the gizmos, yeah, see, I've selected this thing and I'm moving it. Now I'll select one of these floor tiles and I'll move it up. There you go. Now I'll select this box and I'll move it somewhere. And this works because we don't use, we do mouse picking with the actual, like, array versus triangle intersection test. Well, array versus bounding box first and then array versus triangle. But anyway, isn't this amazing? I'm actually very excited. This is like the beginning of the new renderer. So there you go. That is 2D rendering done. In 3D space, of course. Let's try a different scene, actually. Let's try like, let's try Sponsor. Oh, that's a big one. That didn't even... Is it loading it? What happened there? We're still getting a lot of validation errors because I got my thing open. And Sponsor, I think it just refused to open for some reason. Maybe I have to double click on it. Yeah, there we go. It just crashed. Cool. In the allocator. Okay. So we've got some work to do. But still pretty cool. Let's try like prefab sandbox. Even that doesn't work. Okay, so there's some weird logger assert message deadlock. I think there's an assert to do with the anti-component system or something. Okay. Whatever. Yeah. Awesome. I don't know why anything else is affected because we're just doing renderer stuff, but who knows? Thank you guys for watching. I hope you enjoyed this live stream. I'm very happy that we got stuff working. Now, obviously we did that by kind of hacking our way through NVRHI a little bit by specifically bypassing their weird offset things, which I'm not sure about. Man, I just got here. It's okay. You can watch the VOD. It'll stay on Twitch and then eventually go on YouTube. But yeah, so I have to think about like the whole offset situation because I'm not too sure about, like, I don't know if this will work for DirectX, for example, but it should just not work if we write our shaders in HLSL in certain ways and then they don't map to Vulkan. But see, the thing is, I actually don't even think it matters. I don't think we use their offset thing at all. I think we don't care about it. You know why? Because if we write our shaders in HLSL, we can just use this decoration. Because it doesn't matter that they're in the same register. If we manually set a decoration to whatever we want it to be, then it just works. Vulkan picks this up, HLSL uses this, or DirectX uses this. So it doesn't matter, you can have both. And that's what we've been doing. Like, for example, for the GTAO shader, you can see we use a lot of Vulkan binding things because we primarily use it, we only use it with Vulkan, but it's still HLSL and that works fine. So I don't think we need NVIDIA's weird offset table situation that was making everything not work. Yeah. When will the next stream be? Check the schedule on Twitch. If you go to my channel page, I guess, on Twitch, you can see the schedule. It should be Wednesday morning, my time, but you can see what time that is for you there. Is it still worth to rewrite this in NVRHI if it has its quirks? I don't know if it's necessarily NVRHI having its quirks. It's just that, like, this is an existing game engine. There's a lot of existing code here. So you can't expect it to just map to their code out of the box, you know? We have our own way of doing things as well. If this was a brand new project or something, then obviously it probably would just work with NVIDIA system, but because we do a lot ourselves, and there's still lots of Vulkan code running as well, like from Hazel's side, like specifically shader related. So yeah. And also we can modify NV. Like the thing is, when you've already got an engine like Hazel and you're just like taking it into NVRHI land and you're adding like a proper RHI and doing whatever else like that. Like, I don't see this as like, okay, I need to find a product that's ready to go out of the box and I'm done, you know? Like, it's more like, to me, I look at NVRHI as a starting point, not a finishing point. So I'm obviously not afraid to go in there and modify stuff. Now I want to be careful with divergence, because every time they release a new version, you know, or like they push fixes and features and whatever else, I don't want to be too divergent, because then it's harder to reconcile that, like with their changes, if everything's different. So I don't want to just go in and change everything, but changing stuff is just part of this, because I need to adapt it to my needs. It's not about like, let's pick a product that fully fits our needs. It's like, if I was to start from scratch, it would take way longer than if I start from NVRHI. Does that make sense? So that's kind of why. And that's how I'm looking at it, which is why I don't care if it's got quirks. It's still fine. Like, it's still better for me to use it, you know? Anyway, thank you guys for watching once again. Cherno Unplugged is my YouTube channel for stream VODs. So if you missed this project and you want to see it earlier on, then flick through those. I have like little AI generated summaries in the description of each VOD there on YouTube, which has chapters and stuff, so it's a bit easier to follow what I actually did during it. Made a project in Walnut. Can I submit for code review? Sure. What is it? channelreview@gmail.com. Submit whatever you like. Whether or not I'll do it is we'll see, but yeah, just email that for code reviews. Cool. Yeah, anyway, thanks for watching, guys. See you next time. Patreon.com/Cherno, by the way, if you want access to Hazel and you want to help support the project. Goodbye.